In this video, we're going to look at finding the area of triangles and some application problems with the law of sines and law of cosines. So recall from geometry, you had the formula for area of a triangle was 1/2 of base times height, but then these two had to be perpendicular. Oftentimes we don't have that information. We could solve and try to find that altitude value, but we have some other formulas that we can use in order to find the area of a triangle. So if we have a side angle side situation, so I have two sides, so let's say we have side A and side B here, and then we have to have angle C. So it has to be two sides and then the angle included in between those two sides. And if that's the case, then we can use this formula 1/2 A times B, so the product of the sides, and then times the sine of the angle in between them. If instead I have all three side lengths, then we can use this other area formula, which is referred to as Heron's formula. I'm not going to ask you to be able to name that, but you will see it sometimes, particularly in the MyMathLab problems. They'll tell you to use Heron's formula. So the Heron's formula is just the square root of p over 2. P is the perimeter, so you're going to need to know that P stands for perimeter. And then we do that value minus the first side, minus the second side, minus the third side, and we take the product of all of that. So these are the two formulas that we can use depending upon what situations we have. So it's either two sides in the included angle or three sides. So here we want to find the area of the triangle with sides 13, 15, and 18. So if we just kind of sketch that, we have a triangle. One side is 13, one side is 15, one side is 18. So obviously we have a side, side, side situation here, so we can use that Heron's formula. So area is perimeter over 2 times that value minus the first side, that value minus the second side, that value minus the third side, and then we take the square root of that. So the first thing I would do is just come up with your perimeter. So 15 plus 18 plus 13 is going to give us 46. Then we can plug into the equation. So we have to do perimeter over 2, so we can just do 46 divided by 2 is 23, or you can put it in there as 46 over 2. It does not matter. Then I'm going to do 23 minus the first side, 23 minus the second side, and 23 minus the third side. It doesn't matter at all what order you do those in. You just have to make sure you got all three sides in there. And then here we end up with my area is about 95.92. Here's a second example. We want to find the area of a triangle with B is 14, C is 10, and A is 70. So again, I'm just going to make a quick sketch of a triangle here. I know angle A is 70. I know side B, so across from angle B is 14, and side C, so across from angle C is 10. So in this situation, I do have that side angle side situation. So then I can use the other area formula, which is 1/2 A times B sine of C. Now remember, it doesn't particularly matter what the specific letters are. Remember, this just means we're talking about two sides in the included angle. So I'm just going to kind of fill in the information I have. So my two sides are 10 and 14. Doesn't matter what order I put them in. And then we're going to do the sine of 70 degrees. So then putting that into your calculator, we're going to end up with areas about 65.78. Remember to check your mode before you start typing that into your calculator. All right, so here we want to find the area of a regular octagon inscribed in a circle with a radius of 9 inches. So here we're talking about an octagon, and we've been talking about triangles. So what I want you to think about here is that we can divide this octagon up into 8 different triangles. This is a regular octagon, so I know all of the triangles are equal. So we can think about the area of the octagon would just be 8 times the area of each triangle. So if we can just focus on the area of the triangle, then we can find the area of the octagon. So if we just look at one of the specific triangles, so if we just focus on this triangle here, we know the radius of the circle is 9, so that's the two side lengths of the triangle. And then we just need to know this angle here of theta. So theta is going to be 360 divided by 8. Again, because this is a regular octagon, I know all of the triangles are the same, so they're all equal. So that's going to give me 45 degrees. And then I can just plug in what I know over here. So to get the area of the triangle, we're going to do 1/2 of the two sides that we know, which both are 9. And then the sine of the included angle, which is 45 degrees. So we get about 28.64 for the area of the triangle. So then the area of the octagon is just going to be 8 times that. So we end up with an area of about 229.10, and this would be inches squared. Okay, so here we have a word problem talking about a ranger station. So we have ranger station A, and it cites a fire in the direction of 32 degrees east of north. And then we have ranger station B, which is 20 miles due east of that, and cites the same fire on a line of 48 degrees west of north. So if we think about the situation that we have right now, we have A and B, and they are 10 miles apart. And then there's a fire out here, and so this would be the line of sight to that fire. So this first one is 32 degrees east of north, so north would be straight up. This direction is going to be east, and so this is 32 degrees. So we know that this is going to be a right angle here because north, south, east, west are perpendicular. So we can find the angle inside the triangle by doing 90 minus 32, and we're going to get 58 here. All right, so then the second one, remember it says 48 degrees west of north. So again, north is going to be straight up. So west is this way, and this is 48 degrees. Again, I'm going to think this is a right triangle, so if I do 90 minus 48, we're going to get 42 degrees in here. All right, so now if we just kind of think about the triangle, I have these two angles here, and then I have this side at 10. Since I have two angles, I can use the law of sines. But what I need is this angle up here because I have the side across from it, which is 10. So again, here we can use the triangle sum theorem, and we'll get that this angle up here is 80 degrees. So I'm just going to kind of simplify this diagram here for a minute. So if we just kind of extract out the triangle then for a minute here, we have the three angles of the triangle, and then we have the one side across from the 80-degree angle, which is 10. We need to find both A and B because it says find the distance from each ranger station to the fire. So if I start with A, I'm going to have this information, and then I'm going to use that given information. So we're going to do the sine of 80 degrees over 10 is equal to the sine of 58 degrees over A, and then we're just going to cross multiply to solve there. So we end up with about 8.61 miles there. Similarly, we can do the same for B. So again, I'm going to use the given information. We have the sine of 80 over 10 is equal to the sine of 42 over B. Again, we're going to cross multiply. And then we get B is about 6.79, and that would be miles again. Okay, so on this last question, we're looking at a baseball diamond. On the baseball diamond, the bases are 90 feet apart. And then from the pitcher's mound to home plate is about 60.5 feet. We want to find the distance from the center of the pitcher's mound to first base. So we're looking to find this value here. We have these two side measures, and then we have an angle measure. We can't assume that this is a right angle, only if we know that this is exactly at the midpoint would we know that, and we don't necessarily know that information. So we can't assume this is a right angle, so we have to use the law of sines or law of cosines here. So since I only have one angle measure, we're going to use the law of cosines. So this variable that I'm trying to find is c, so we're going to say c squared, and then a and b can be these 60.5 and 90. It doesn't matter which is which. So 60.5 squared plus the 90 squared, and then minus 2 times the 60.5 times the 90, and then cosine of 45 degrees. Then I'm really just going to go do this calculation in my calculator. Then I'm just really going to do this calculation in my calculator, and we end up with about 63.72 feet.